Okay, my name is Kehinde Elisha, and I'll be presenting today some information about uh, CompTIA network. This is for HIN 615. My professor is Professor Dwayne Bendel, and I'm creating a special PowerPoint, like a couple of slides, like up to 6 or 7 slides, just specifically to elaborate better on private IP addresses and classes. That's for the IPv4. I didn't go into IPv6 because IPv4 actually was more used or utilized during the entire simulation. Okay, so CompTIA, what does it really mean? Because when I saw it, I don't really know. But then the definition says CompTIA Technology Industry Association is a non-profit association that was created in 1982 as the Association of Better Computer Dealers. CompTIA Network is a vendor-neutral networking certification that is trusted around the world. It validates the essential knowledge and skills needed to confidently design, configure, manage, and troubleshoot any wired and wireless networks. Definition, summaries, highlights of terms. A unique IP address is required for each host and network component that communicates using TCP or IP and can be assigned manually or by using dynamic host configuration protocol. The IP address identifies a system's location on the network in the same way a street address identifies a house on a city block. Just as the street address must identify a unique resident, an IP address must be globally unique to the internet network and have a uniform format. So this makes a lot of sense, and this is the more reason why I'm breaking this part of the whole topic down, because truly it is kind of what is going to really guide us. It's going to help us get through the simulation and having a deeper understanding of what the IP4 means. IPv4 means kind of would help, and would make the material less intimidating, or the simulation less intimidating to go through. So an IP address consists of 32 bits. Instead of expressing IPv4 addresses bits at a time using binary notation, it is a standard practice to segment the 32 bits of IPv4 addresses into 4 8-bit fields called octets. The octet is converted to decimal number base 10 from 0 to 255 and separated by a period. This format is called dotted decimal notation. The following table provides the example of the binary dotted format, the decimal format, which is going to be on the next page. The IPv4 address types and classes. Okay, so we have on this PowerPoint we have like A, B, C, D, and E. But really, I'm going to go to the next slides because that one is more important, and that's mostly what we're going to see. And I will go more into these areas, like what 192 means or what to do, as I go further into the lecture, into the presentation. So private IP addresses and classes. Class A, Class B, and Class C. So I'm going to go straight to Class B or Class C, either one. I'm just going to talk about Class B, for example. We use that a lot during the simulation. And that really goes with, and it can be formatted in different ways. Sometimes at the end of this, we can have like 1/24, for example. And those all mean something. And the 24 end up becoming the subnet mask. And then instead of writing 1/24, it interprets into 255.255. And it goes on like that. That was what the pattern that I noted during the simulation. So I hope this kind of breaks down and kind of clarifies a little bit what the numbers mean when they are seen during the simulation. The class A, they have classes A, B, C, D, and then the private networks will be the one with 172, 192. They just start that way. And the sub-mask networks, they usually start with like 255, and then the trailing numbers is divided in a different way too. And of course, the address range will have to have different categories under it as well. Okay, so now I'm going to follow through to the software for further explanation, and this ends the presentation for the simulation itself. This ends the presentation for the IPv4 address types and classes. Now I'm moving on to CompTIA. So now I'm going to go straight to my simulation, which I couldn't really wait to get started on. And I'm going to go straight to the ones that we're given to do in class. Um, the assignment was stated that we have to go through the grade and present it from there. So that's exactly what I'm going to do now. Under the matching, we were supposed to address the IPv4 addresses, types, and classes. That was done and completed. The third one is security terminology and descriptions. That was completed as well. And I'm going to go next to the types of networks, threats, and attacks. That is a completed task also. And then security appliance, terminology, and method was successfully completed and graded as well. And also, so now I'm going to go to the next group of assignments. That is the graded, that is the drag and drop. So now one of the first one was to identify common CAT writing. That was done and successfully completed and questions properly answered. And the next one was supposed to be the network topologies, which was actually my very favorite one. I did miss one question out of that, but truly this was I actually went through this based on logic, based on the shape. I was able to come up with the answer. So I find this really, really interesting and exciting. The third point is supposed to be create a straight cable test and test it. This was quite challenging for me, but I got through it and it was successfully completed. Another one that was done supposed to be create a crossover cable. That was done also and successfully completed and answered in full. And another one supposed to be the match command output to command, which I really find exciting as well. I realized I actually can read these things. I realized for the first time that the NS lookup, IP config all mean something, and they actually pull up something on the computer. For the first time, this makes sense to me. I never take time to look at it whenever I'm using my computer, but for the first time, this made a lot of sense to me. Which I really had fun with the entire program. I did a couple of extra things that was not required in class, but that was just because I was having fun with the program. The third group of assignments is the simulation, which actually took a lot of my time, but I had fun with it. It was pretty much pulling together everything I was learned from the matching and the drag and the drop. So it makes sense to spend a lot of time in those top two assignments. That way this simulation will make sense. And I'm going to go through my grading for that one as well. The first topic was supposed to verify a data link connection from a computer to a network. And that was successfully done and completed. I got to the end of it, and I'm going to explain as I go further. The next step was supposed to be configuring a client's network adapter with an IPv4 address. That was successfully completed and neatly done as well. Using ipconfig to discover network settings. That was done and completed as well. Using a ping to troubleshoot connectivity. I passed it and it's completed and neatly done. Using ping to troubleshoot connectivity was done and completed as well. Using a harp to discover a MAC address was passed and completed. Using an extended that was not extended was not required, but I did it because I was curious about the material. That was just an extra thing that I had to do. I did on my own time. And then using the IPONG, ping, harp, tracers together to troubleshoot. I did that and successfully passed and did really well on the simulation. And then using using manually configuring was the next one, and manually configuring was perfect and actually pretty much applied to my day-to-day life because it has to do with wireless, so I'm kind of familiar with it, making the simulation a lot more easier. Configuring small office or home office router. I'm a registered nurse and we do this a lot in the office, so I was able to actually get through this in a very quick and fast and neatly done as well. Same with troubleshooting practice. This was successfully done as well. Configuring static solution workstation. This was actually a little bit of a hassle, but I was able to get through it with multiple tries. And then using NX lookup was successfully done as well. Um, and then DNS troubleshooting successfully done as well. And configuring the internet router was done and completed as well. Using NetStats troubleshoot connectivity was completed as well. And creating network users domain was done and completed as well. And then lab performance overview was done as well. And this actually I found really interesting because a bunch of times I tried to connect to another computer, another internet outside. Now that this kind of breaks it down on how to do that. So um, also another area that was dealt with was using tracer troubleshoot connectivity. That was done as well. And so now I'm going to go ahead and I'm going to go ahead and start from the beginning and break down each, what it means, what it does, and the benefits of each. Okay. First of all, the IPv4 was the one I found really interesting. Um, I didn't understand these codes at first, and that's why I had to actually go back and create a slide explaining it. And it's just talking about the types and classes and address terminology also. Well, sorry, that is now a required assignment. Um, the next assignment is supposed to be identify troubleshooting commands to use various tasks. This was a required one, and I was able to apply the task by reading each path, each definition, and it went here to talk about verify TCP IP settings, including the DNS servers. This is the way, a code to get that done. And the test connection with a remote machine, ping, is a way to get that done. Discover the MAC address of a network device, and this is a code to get that done. And getting that done has to be done in actuality. So what I can say is unless I pull up a screen to apply to type in the words and see how it works, there is really no better way to really explain this. And security terminology was completed as well. And this one is just defining like a personal condition within an organization possessing a potential what does that mean? Internet threat, which actually gave itself away. Internet threat within an organization, somebody from the inside is possessing a threat. So that makes sense the way that it definitely is quite intuitive. And then an organizational framework that defines assets to be protected and assigns authority for doing so. That will be a security policy. And then generic term for individual engaged in attempts to circumvent security measures protecting data. That will be an hacker, which is a very, very common term. A lot of these terms actually familiar with based on the classes that I've taken in the past and based on the research work that I have done. So types of networks and threats and attacks, which I actually find interesting. I never knew phishing meant anything. I didn't think it was a proper definition. I see DOS, DDoS. It didn't make any meaning to me. Now I understand. I thought virus was actually a term that was made up until I went through this simulation and I realized actually a true word it actually exists in the terminologies within the computer systems. And then the lab performance overview, which is going to be like the honest part, tells me about um, how using multiple honest parts used to tandem for larger networks monitoring, used to attract, detect, or counteract uninvited intrusions into information networks. So it means a couple of definitions and probably more, so more applicable, especially with the security issues that we've been having in the institutions. Okay, so now the drag and drop is supposed to be the next one on the list to go to. Okay, so I really couldn't wait to get to this because I found it really exciting, very, very involving. I felt like I'm really doing something in actuality. So to identify, it says to identify common problems. So what I find unique about this is that what I find unique about it, I just observed that some of the numbers were missing. That was the way I first of all kind of like rationalized my answers. And I felt like, well, one number is missing here. That means there's an open way for the wire to, wire tester to go through. I just kind of went through my answers that way, not necessarily applying the common principle. And then the network wire tester was actually I picked short because I figured it has to be short because no number is missing and everything is matching up. This one I kind of just did it intuitively. It was the only one left, and I figured, well, that's gonna be what's gonna be left. So eventually, I went ahead and like to read up on the definitions and look it up, and I realized it actually made sense the way it's set up. The next one is supposed to be the network topologies, which was my favorite, like I highlighted before. The way I went with this is supposed to be, this was supposed to be hierarchical. In an organization, I just understand that some people have a director up here, some people have like a, assistant or vice president, and maybe, manager, and then under the manager, I'll probably have like a unit secretary, and under the vice president, I'll probably have some like, some kind of probably secretary as well, and under this we have some other kind of levels. So that is the way I came up with the hierarchical. And of course, this one says point to point. I just went with that because it says there's one point pointing to another here. So there are two things pointing to each other. So there are two things pointing to each other, and I feel like that's the way I came up with that answer. Not necessarily correct definition, but it was quite intuitive. It was obvious. And hub and spoke. I just felt like, well, there's a hub, and from the hub, things are protruding out. And this certainly looks like a bus. It was a perfect definition for it. Looks like a bus, and this called full mesh. The full mesh is actually, well, looks like mesh tied together or mesh arranged together. Partial mesh supposed to be partial mesh was similar to the full mesh, except that it has less around it. That's the way I came up with that too. And except this one that I should have actually thought about this hub, and I should have thought about this as a hub and spoke as well, because the only difference between this hub and spoke and this hub and spoke right here is just the positioning. One is facing down, one is facing up, and one is facing down. But that completes the network topologies. But the network topologies usually is just the way the things are arranged. That's usually the main, the basic definition of it. Uh, you know, and this tells me the codes that I need to generate all these numbers. That's what the main purpose of these codes are for. And of course, this is interesting about matching up cables. So their strategy is about what a straight line cable is and all that. And the definition of a straight line cable is supposed to be um, I actually have a definition here that says common Ethernet cables are straight, and cables are categorized according to in Cat5, Cat5e, or Cat6UP cable. Um, but there is just a broad definition for which I'm not going to go into, so I will not uh, bore you with this presentation. And the crossover cable, I realize the main thing that we're doing with the crossover cable is just that one hand is on the other side. It's kind of crossing over. Um, it's pretty much color coded, and there's one color has to fall on one side and the other color has to fall on one side. I don't have a pretty good grasp of it. I will have to do more reading on that, but I was able to successfully complete the project. Now we'll go to the simulation part. The simulation is supposed to be a way to verify the connection, to verify a data link connection from a computer to a network. The needed time to complete the lab. The computer. The interesting thing about it is it's just pretty much
how to connect to a computer network. How many times do we have to do that? We do that a lot, especially if it's a cable to a computer. It's not like the regular wireless. And if it's a regular wireless, this applies to that too. And then configuring the network uh, adapter to IPv4 address. This took us to the process, and this is when the numbers became relevant. The numbers that was presented on my PowerPoint slides. This will enable us to manage a wireless network, to change adapter settings, to change the advanced sharing settings, and it takes us through certain steps on how to get to this part. And there are steps as well to get to this. This is supposed to be like Internet Protocol version 6, TCP IPv6 properties. Using ipconfig to discover network settings. So the lab performance of a few. You should So the question here is actually interesting. Actually, it says how many Ethernet adapters are indicated by the output from one ipconfig. So I actually went with this answer. It says more than one Internet adapter available, which makes sense. The main reason for the configuration is just to sort of kind of spread the surface, create more surface area for more internet connection. So using the ping troubleshoot connectivity, device configuration, great. This one also came up with some case studies that are interesting, and it was all addressed. And my main thing, this one is still all talking about the internet. It's kind of about the same thing, but going through different routes. Configuration, using HARP to discover a MAC address, using extended ping to troubleshoot, using ipconfig and HARP to troubleshoot, using basic Linux troubleshooting commands. Manually configuring wireless signals on a small office. And this is so interesting because actually I've seen this is like a new setup. I've seen a new company setting up a computer before and they had to go through these steps. It never really made sense to me. Now it makes more sense what they're really doing and what it means and why they're doing what they're doing. So troubleshooting practice is supposed to be how things will go wrong in life, things will go wrong with technology. So knowing how to troubleshoot is definitely an asset. Knowing where to go to fix whatever problem that will go through, that the computer go through is important. And this is what the troubleshooting is all about. So static host name resolution on a workstation. This is supposed to be sort of, I would say, extracting information or fixing a problem. I wasn't quite sure. It was a pretty quick swim simulation. There was not much words to read about it. And then the NS lookup supposed to be a way to actually get to some details. And the DNS troubleshooting simulation supposed to be just taking me to a website in a different way. I know I punched some numbers in the address bar. I did the www.example.com, it didn't work. And somehow when I dropped my number here that started with like 192, it worked. The significance of that I don't quite understand yet, but I do know that they're trying to say here that, showing us a way to troubleshoot. And configures IP address, I had a little challenge with it, and that is the one that I got halfway, and then for some reason it didn't let me finish it. But I got halfway and I got stuck. It would not take the rest of the number again. And then using non-stats troubleshoot connectivity. Configuring lab performance, VPN client. Okay, so now this is very, very interesting. Configuring a VPN client. For example, this one you have to be very, very mindful. If you have a client that has a firewall on their computer, the firewall can prevent some unrecognized website from going through. So if you have a fire, so actually there was a question about that too. So if you do have a firewall and the computer wants to stop this from going through, then you're gonna have to like find a way to probably bypass it so that it doesn't block it from going through the particular network that you want to go to. And creating network users domain controller. This I find really interesting as well. I don't know how applicable it's gonna be. I imagine it's just the same thing as creating a name for somebody. Perhaps it's gonna be perfect for a big organization that want to create name and create names for the employees. And this completes uh, my assignment. Thank you.